Hi everyone, this is the part 2 of the second lesson of our chemistry unit, Properties and Classification of Matter. In this lesson we're going to talk about the classification of matter and a little bit on chemical reactions, very brief because a lot of that's going to be coming up later in the unit. As we move forward, please keep in mind that this table here, or this diagram, is something you've probably come across before. It's a way to help us define and differentiate between the different types of matter that we'll come across in our lives. So we start at the top and we have matter, and the first kind of breaking part is into a pure substance or into a mixture. And what we want to do is understand, well, what does that mean, first of all? A pure substance means where every molecule that you are holding is the exact same. So what I mean by that is let's pretend I held a pure substance and I had a piece of gold in my hand. Well, if I could zoom in and look at all the atoms in that pure substance of gold, every single atom would be a gold atom. Every single one would be a gold atom, okay? There's nothing else mixed in there. Everything is made of the exact same atom, okay? Another example I could give you, pretend I had a spoon and I held salt in it. So if I could just zoom in, every molecule, every little bit that I have on that spoon, every molecule is made of NaCl or table salt. There's nothing else mixed in. There's no sand. Everything's the same. It has the exact same chemical formula. Okay, so a pure substance is when whatever you're holding, every single molecule has the same composition, the same makeup. Now, let's break this down a little bit further, because what we're looking at now is we're at a pure substance, but what makes you an element pure substance or a compound pure substance? The element, I want you to think of the gold example. That's where you're looking at something, and every single atom is the exact same. For example, every atom in this case is gold. Okay, so that means each one of these is a gold atom. Furthermore, you can't break down an atom. An atom is the smallest thing that we have. We cannot break it down any further. So this would be a pure substance in the element category because every atom is the exact same. Of course, I could do that with another atom if I wanted to. Pretend now that every atom on this right here is silver. That means I cannot break it down any further, and every one of these atoms, if I could zoom in with a microscope, is a silver atom. Pure substance in the element category. If we go to the other side now, we have a compound. Well, what does that mean? I want you to pretend, so we're on this link right here, pretend I have, let's say, a cube, let's just say we have a cube of salt, okay, a little cube of salt. What I'm saying to you in this case is I know that salt, a molecule of salt, is composed of Na and Cl. It's a sodium atom and a chlorine atom. We'll come across that later. That means every molecule inside of this salt little cube is NaCl, nothing else. But you see, it's a compound, everyone, because we've taken two, or more atoms, and we've put them together, and we know that every one of these molecules is the exact same thing, and that's why it's a pure substance, because everything is the same. Only difference is sometimes you have an element pure substance, or you can have a compound pure substance. Moving along, I think what I'm going to do here is I'm going to do this kind of in one shot. The other category is when you have matter and it's a mixture. A mixture, of course, is when you have two or more things mixed together. As you can see on the chart here, you have homogeneous mixtures and heterogeneous mixtures. Pretty easy going here. A homogeneous mixture is when you have, let's say, two or more things mixed together, but it looks like it's all the same. For example, pretend you had a glass of water and you dissolve some salt in there. It looks just like water. you would never know that there's salt inside of there. That's a homogeneous mixture because we have multiple things put together, but it looks like just one. A heterogeneous mixture is even easier. That's where we have two or more things put together and you can see the different ingredients per se. Think of cookie dough. When you look at cookie dough, and if it's chocolate chips, you can clearly see the different parts in there. You can see the dough, the chocolate, maybe you can see some of the flour. The point is, that's a mixture, and you can see the different parts of it. Okay, moving along, I'm going to skip a couple of slides here. You can read that on your own time or read in the textbook. The other part of this section here is chemical reactions. Most of these you've come across before. Chemical reactions, what are they? To observe a chemical property, you must observe a chemical change. A chemical reaction is a process that occurs when a substance or substances react to create different substances. Chemical reactions always involve the production of a new substance with their own physical and chemical properties. Energy is always absorbed or released during a chemical reaction. Now, the fun part of Science 10 chemistry is we're going to get into how to write chemical reactions, how to predict them. It's going to really lead into some Chemistry 20. The point is, I just want you to be aware of some of the main properties here of chemical reactions and what takes place. Finally, how do you recognize a chemical reaction? Chemical reactions always share certain characteristics. All reactions involve the production of new substances with their own characteristic properties. State at room temperature, melting point, color, density. All reactions involve the flow of energy. This may be detected by a change. In other words, something might get cold, something might get hot. Many reactions cause a phase change, such as the formation of gas, bubbles, etc., etc. So remember, a chemical reaction is kind of the cool one. That's where you're at a very small level, your atoms are rearranging. And even though you and I can't see the atoms, we will see various characteristics that help us say, you know what, that must have been a chemical reaction because maybe something exploded or something got colder. The point is, chemical reactions have numerous characteristics, and I would like you to be aware of those. And specifically in your textbook, you're looking at about page 15 to 17. Okay, let's move along.